we finished with statics and we're moving to electricity. And we have a simple electric circuit which is made of a cell. We have the negative and the positive terminals of the cell. So the cell is the device, the part of the circuit that gives out the energy, is the place where the energy is stored. And then we have a switch, and we have here the symbols for all of these elements of circuit. So we have the cell, and then we have the switch, which can be on and off. This time is off, and you see we have a gap there which prevents the circuit from working. Then we have the bulb, which is just a resistor. The bulb is what we're using, but it could be anything that uses energy there. It could be your hair dryer, it could be a toaster, it could be an electric oven, practically anything that uses energy. And then we have an emitter. The emitter is, as you see, is placed in series, so is placed in the main circuit. The emitter counts the charges, counts the current. So, for example, as you can see, I have here in pink, I've drawn the way the electricity is moving, and the arrow shows the direction of motion. So the current is coming in and is going through the emitter, and emitter counts 1, 2, 3, 4, 5, 6, and gives that number out as amps. So these electrons are moving through the emitter, moving through the wire, which has low resistance, and then when they get to the bulb pretty much uses all their energy. So in the bulb there is a lot of friction. If you rub your palms, like we've done the demo in the class, you know what it means. So rubbing your palms harder, your palms harder means that there is a lot of heat going on there, which will in the case of the bulb, it just translates into light being given out. Okay, here we have next to the bulb we have a voltmeter, which is placed in parallel with the bulb. The voltmeter is not a piece of the circuit, that's why this is still a simple series circuit. So the voltmeter is placed in parallel. It just checks how much energy is available, so how much energy went in compared to how much energy is coming out, and that is practically the voltage. And then the current comes back. In this situation it doesn't work, so the switch should and has to be on. The switch is on, so it goes back into the cell. Those electrons get more energy and they go out again, and the same process continues over and over again. So the current is the flow of electrons. Okay, what else we have here? So the current is the fact that the electrons flow, so the electrons are moving. The current is symbolized by I, and then it's measured in amps. In amperes, the voltage is how much energy electrons have when they're moving around, practically how much energy it's given to the electrons. The symbol is V, capital V, and the symbol for the unit is volts. The resistance is how easy or difficult it is to move through the wires. For example, the wire has a low resistance. That means it is, and the emitter, it is very easy to go through it. That means they don't get hot, and it's something that we don't want. We don't want the wires in our devices to get hot. And then, but then when it gets to the bulb is difficult to go through the bulb, which means it has a high resistance. That means a lot of friction, a lot of heat. In the case of the bulb, it gives off light. On the bottom, I just showed that if you have 1 amp, let's say you have one electron going through, 2 electrons going through, that means more current, 3 electrons going through at the same time. You see, they're at the same position at the same time. That means 3 amps of current. If I move a bit forward, the symbol for a cell is just a simple 2 vertical bars. One is smaller, shorter, which is the negative terminal. One is longer, which is a positive terminal. In the case of a battery or the power pack, we have negative, positive, negative, positive, and there can be a lot of them. So practically a battery is a lot of cells put together. If I go back to a simple electrical circuit, so we have cell, emitter, bulb, voltmeter, switch, cells. cell provides energy for electrons. So if I have a 2-volt cell, it will give those electrons less energy than a 4-volt cell, which will give the electrons less energy than a 6-volt cell, which will give the electrons obviously less energy than a 12-volt cell. That means for the same electron, if there is a 2-volt cell or there is a 12-volt cell, there is 6 times more energy than that electron receives from the 12-volt cell. Let's put it like this. The 2-volt cell would be like the electron gets 1 Snickers bar, and then 12 volts means the same electron gets 6 Snickers bar to carry around, so 6 times more. The electrons which make the current, they move with the energy. So practically the cell gives the electron the energy, the chocolate bar, going back to the example from earlier, and then the electrons will move with that chocolate bar, and they will try not to lose it on the way. So for example, the current, again, as I mentioned earlier, we have amps. So we have 1 ampere, which means less than 2 amperes, less than 3 amperes, less than 7 amperes, obviously. That means, for example, a bulb that has 3 amperes will be much, much brighter than a bulb that has 1 ampere going through, because there is more energy moving around. An ammeter. The ammeter is the device that's symbolized by A. Sits in the circuit, keeps track of the electrons, so keeps track of the current. It just practically counts how many electrons, how much current goes through. It's measured in amps. The symbol will be A. And the voltmeter is always next to the device that uses energy. For example, this one is next to the bulb. It always sits there because it wants to see, hey, how much energy this device got, and how much energy is this device practically using, how much energy is eating, how much chocolate is the bulb eating out of what the electron is bringing. So checks how much energy is available, is measured in volts, and the switch is just a piece of device that allows you to turn the circuit on or off. And this is it for the moment. Thank you.